Hi guys, welcome to this fifth tutorial in this series of programming PIC microcontrollers with MPLAB XC8. In this tutorial, we're gonna learn how to use an LCD display. LCDs are alphanumerical or graphical displays. They are frequently used in microcontroller-based applications. There are many devices in the market which come in different shapes and sizes. Some LCDs have 40 or more characters length with the capability to display several lines, while some others display can even be programmed to display graphic images. As we can see in this demonstration, we've got a 16 by 2 lines LCD. It basically means it can display 16 characters in 2 lines. We can even have other LCDs like a 40 by 2 which can display 40 characters in 2 lines, a 40 by 4 which can display 40 characters in 4 lines, and so on. Some LCDs can be programmed to display graphic images like this one, a 128 by 16 graphic LCD. It can be programmed to display simple graphics like chart, graphs, or even rectangles, circles that might be needed in your project. In terms of interfacing technique, we can group LCDs in 2 categories: parallel LCDs like this one and serial LCDs. A serial LCD is connected to a microcontroller using one data line only, and data is transferred using the RS-232 data communication protocol. Serial LCD are generally much easier to use, and they only use one data line, which can help you to save some more pins of the microcontrollers. But the problem, they are more costly compared to the parallel ones. In this video, we're gonna discuss only the parallel LCDs, as they are cheaper and are used more commonly in microcontroller-based projects. One of the parallel LCD is the popular Hitachi HD 44780 controller, which is one of the most popular LCD controllers used in many LCD modules in industrial and commercial applications. This module is monochrome and comes in different shapes and sizes, usually with character length of 8, 16, 20, 24, 32, and 40 character length in 1, 2, or 4 lines. In this demonstration, we are using the LM016L, which is a 16 by 2 line LCD. It can display 16 characters in 2 lines. If you need to display more characters, then you'll have to scroll left or scroll down. This LCD display generally has 14 pins, which are marked on the PC board, with our models have 16 pins if the device has a backlight built in. In this demonstration, this LCD module has a green backlight built in, but other colors are also used in other devices, like a blue light, which is also a common feature in some other LCD displays. The first pin is VSS, which is a ground pin. You can connect this pin to the ground supply of the circuit. The second pin is VDD, which is a positive supply of the LCD. You can connect it to plus 5 volt of the circuit. The third pin is VEE, which is a contrast pin. It can have 0 up to 5 volt. That's why generally it's connected into the middle pin of a variable resistor, so that the contrast of the LCD can be adjusted. The fourth pin is RS pin, which is a register select pin. When this pin is set to 0, data 0 to data 7 are interpreted as commands, and when this pin is set to logic 1, then data 0 to data 7 are interpreted as data. The fifth pin is RW, which is read-write pin. When this pin is set to 0, or if it's grounded, then it is in write mode. The microcontroller can write data to the LCD. But when this pin is set to 1, if it's connected to a microcontroller, then it's set in read mode. Then data can be read from LCD to the microcontroller. As usually, we don't need to read anything from the LCD. To save some few pins on the microcontroller, it's usually a good idea to connect this pin to ground so that we can only write to the LCD. Pin 6 is the enable pin. When this pin is set to 0, then the access to the LCD is disabled, but in normal operation, this pin is set to logic 1. Pin 7 to pin 14 are data pins. If the LCD is connected in 8-bit mode, then all these pins are connected to the microcontroller. But when it's connected in 4-bit mode, like in this demonstration, then only pin 11 to 14 are connected to the microcontroller. The LCD display contains 3 memory blocks. The first memory block is the DDRAM, which is a display data RAM. This memory block is used for storing characters that should be displayed on the LCD. Each character occupies one DDRAM address. The first line, if the cursor is standing on the first line on top left of the LCD, this address is address 0 in hexadecimal. The first line addresses are from 00 to 27. The second line address starts from 40 to 67 in hexadecimal. Let's say if I want to move the cursor to the beginning of the second line, then I should set the DDRAM address to 40 in X. For LCDs with more than 2 lines, it's always good to check the datasheet for more information. The second memory block is a CG-RAM, which is a character generator RAM. This memory contains the default character map with all characters that can be displayed on the screen. The addresses of the CG-ROM memory locations match the characters of the ASCII table. This simple table here shows the corresponding symbols like 0, 1 if you want to display 1, 2, a $sign, or a percentage sign. These are the corresponding code that you can write in binary. The last memory block is a CG-ROM, which is a character generator ROM. This memory is used to create your own characters. Let's go to the code and see how we can write some code that can be displayed on the LCD. In this demonstration, we're just going to create a simple program that can display on the first line of the LCD student companion, and on the second line we're going to display LCD display. Microchip XC8 LCD library provides a large number of functions to control text-based LCDs with 4-bit and 8-bit data interface. If you want to access the help file, you can press F1. The help file is going to load. In the search tab, LCD, press enter. Then it's going to show you all the articles related to the LCD. The LCD function description shows all the functions that can be used when you're controlling the LCD. We've got the busy xlcd. This function is used to check if the LCD is still busy. It's always good to use this function before sending any other function to make sure that the LCD is not busy doing something else. Okay, I'm just going to expand this. so that we can see clearly. The Open xlcd is used to configure the input-output lines of the controlling LCD and initialize the LCD. It's always good to start with this function so that you can configure the LCD whether you're gonna use it in 4-bit mode or in 8-bit mode. The putc xlcd function is used to write a single byte to the controller. The put s xlcd is used to write a string to the controller. The set DDRAM address is used to set the display data address. Let's say if you want to move to a specific location on the LCD, or if you want to move to the second line or any line, then you can use this set DDRAM address. This is an example how you can write a code to initialize the LCD. Let's say you want to initialize the LCD to use all the 8-bit, then you can write Open xlcd 8-bit and line 5 times 7. This 5 times 7, it is the size of each character used on displayed on the LCD. The other thing that is important when using the LCD is the delays. Let me just search LCD delays, enter. The LCD library requires that the following delay function be defined by the user before using the LCD function. We've got 3 delays: the delay for 18 TCY, which is a delay of 18 cycles. Then we're gonna need a delay of 15 milliseconds and a delay of 5 milliseconds. You always have to declare these delays before you can use any other function of the LCD. Let us go to the code and see how we can write all these delays and use these functions. The first thing that I did in this program is to initialize the LCD. Instead of writing everything in the body, the main program, I just created separate functions. The first function is init xlcd, which is gonna initialize my LCD with the default values that I want. The first line is Open xlcd. I'm just initializing my LCD. I configure it in 4-bit data mode, 4-bit. If I wanted in 8-bit, then I could have wrote 8-bit and lines 5 times 7. The second line is to check if the LCD controller is not busy. I use the function busy xlcd. If the LCD is busy, then it's gonna remain on this line. Once it's finished, then it's gonna go to the second line. In this line, I use the command xlcd, which is the function that you can use to write a command to the LCD. I use in the command 06 in X simply means move cursor right, don't shift display, and 0C in X simply means turn display on without cursor, so that I don't have the blinking cursor on the LCD. This simple table shows the instruction that you can send to the LCD. If you send 1, it's gonna clear the display. C, it's gonna display on, and cursor, it's gonna turn the cursor off, and so on. But because it's always difficult to remember the numbers, then you can use this command instead of using numbers. You can write the function write command xlcd d off, then this is gonna turn display off. If you write d on, then it's gonna turn the display on. Cursor off, it's gonna enable the display and it's gonna hide the cursor. Blink on, if you want to enable the cursor to blink, and so on. Let's go back to our code. In the second function, I'm gonna create 18 cycles delay, which is required to operate the LCD. Assuming a microcontroller clock frequency is 4 MHz, the instruction cycle time is gonna be 1 microsecond. With a clock frequency of 8 MHz, the instruction cycle time will be 0.5 microsecond. 18 cycle delay can be obtained using the NOP statement, where each NOP operation can take 1 cycle to execute and basically does nothing. The end of the function with no return statement takes 2 cycles. When a return statement is used, A BRA statement branches to the end of the function where a return 0 is executed to the return function, this adding 2 more cycles. So if I can use 14 NOP statement and a return function, it can create 18 cycles. The third function I'm gonna use is the delay of 15 milliseconds. Let's press our help again and type delays. Enter. If I write delay 1 TCY, it's gonna create a 1 instruction cycle delay. A delay 10 T, it's gonna delay in multiple of 10 instruction cycle, and so on. So if I can go back to my code to generate a delay of 15 milliseconds, because we are using a clock frequency of 8 megahertz, it's gonna take us 0.5 microsecond for each instruction to be executed. So to create a delay of 15 milliseconds, we can use a delay 1 KT, which is 1000 multiplied by 0.5 microsecond multiplied by 30, which is going to give us 15 milliseconds. To create a delay of 5 milliseconds, then we can do the same thing, 1000 multiplied by 0.5 microsecond multiplied by 10, which is going to give us 5 millisecond delay. In my main program, the first thing to do is to call the initialize xlcd, which is going to initialize my LCD with all the default that I need. Then I can use the function put rs xlcd, which is a function that you can use to send a string of data to the LCD. In my case, I use student companion, which is going to display student companion on the first line of the LCD. Then I'm going to need to shift my cursor to the beginning of the second line. The beginning of second line address is 40 in X. Then I can set my DTRAM address to 40 to shift it to the second line, beginning of the second line. And once my cursor is at the second line, then I can write LCD display using the same function. If I want to write just a single byte, let's say just L, then you can use the put R xlcd function instead. Then I can create a while one loop so that my program can keep looping continuously. Let us build the project, the code, and see if it's gonna run. Okay, it's building. Okay, build successful. Let us go to our simulation. Run student companion on the first line, LCD display on the second line. If I want to display the cursor, a blinking cursor, then I can write a command of 0f, run, build successful, stop, run again. Then you can see it's displaying a blinking cursor. This is important, especially if you want the user to set some configuration data on the LCD. If maybe somebody gonna press something and it's waiting for data, then you can set the cursor to blinking on. So this is basically how you can write. Let's say if I want to write hello world to the first line of the LCD, I can just write hello world. Okay, build the project. We go to the code, stop and run the simulation again, and you can see it saying hello world on the first line of the LCD and LCD display on the second line. If let's say I want to start not at the beginning of the first address of the LCD, let's say I want to start, let's say at the 5th address, I can say, I'm just gonna copy this quickly of Control C. Let's say I want to start from the 5th address. Okay, run, build. Okay, stop, run the simulation. Then you can see, instead of starting from the beginning of the first line, I start at the 5th address of the LCD. Basically, this is how you can use an LCD display using MPLAB XC8. Thank you very much for watching this tutorial. Don't forget to subscribe to our YouTube channel to receive more tutorials in the future. And if you want to learn more about this tutorial, you can visit Interfacing LCD Display with PIC Microcontroller on Student Companion website. Thank you.